start this section, you should have the assembly file of the Stirling engine open, as well as the flywheel part. To open the drawing that was already created for this part, we could use the open command and then browse for the drawing. But because SolidWorks knows that we created a drawing for this file, all we need to do is right-click an empty space and expand our right-click menu with the arrows at the bottom of the menu. We should then see on the menu an Open Drawing option. Select it. When the drawing loads, we have what would be referred to as a working drawing, or a print. These are what we use to communicate our design to others. On the main portion of the drawing, we see that the flywheel has an overall diameter of 4 inches. Remember that number, because we're going to make a change to the part and watch it update. Zoom into the bottom right corner of the drawing, and you can see on the title block that the description is flywheel, and the part was modeled by A. Wutmo. Both pieces of information that were carried over from the custom properties of the part. Let's go back to the part and change some dimensions and properties, and then we're going to watch them update the drawing. When we do that, I want to teach you another neat little trick for switching between open SolidWorks files. You may be aware you can use Alt-Tab to switch between open applications. Well, if you hold Control and press Tab, you can switch between open SolidWorks files. Each time you tap Tab, we switch to a preview of the next file. Or you can move your cursor over the preview you want. We want to open the part file of the flywheel, so ensure the part is highlighted and release Control. With the part open, open the Custom Properties task pane, and change the modeled by name to your name. I'm going to go ahead and enter B. Smith, because the modeled by name is already my name. Also, go to the description and change the text to Flywheel 2. So, we've updated some custom properties, but before we jump back to the drawing, we're also going to change the 4-inch dimension on the part. So, double-click the front face of the flywheel, and you should now see some dimensions appear. We want to change the 4-inch diameter, and if it's hard to see, you may need to rotate your part around a bit. To edit the 4-inch dimension, click it. A Modify window opens, and we can enter a value of 120 and add mm for millimeters. Next, press the red and green lights to rebuild the part. When you do, there are a few things that I want you to notice. First, the whole flywheel grew to the new size. Also, the inside bore grew with the outside diameter. And that's because when the part was modeled, we captured our design intent. So, as we change the model, it maintains our design parameters. And this is what we refer to as parametric modeling. Now, the other thing that we did was we entered a number in millimeters, and SolidWorks automatically converted it to inches. This is important to notice, because everything that we do in SolidWorks is in full scale. When we work with different units, all we're doing is changing the dimensions that are displayed. Then, the drawing merely takes the full-size SolidWorks model and scales it down to fit on a piece of paper. If you want to design a metric part, make sure you use a metric template so SolidWorks knows you're entering metric values. And the same goes if you want to design in inches. We need to make sure SolidWorks understands it's inches we're entering. I've had a lot of people say that they've accidentally drawn a part using an inch template but entering metric numbers. And now you have a part that's out of scale. Unfortunately, there's no automatic way to correct that issue. So again, you need to keep that in mind that we're drawing in full scale when we're working in SolidWorks. So we've made a change to a dimension and some custom properties on the part. Let's tab back to the drawing. Hold down Control and tap the Tab key until the drawing's highlighted. On the drawing, we can see the part has now updated to the new dimensions, and if we were to look at the custom properties, we've noticed that those properties have also updated. Finally, let's tab over to the assembly. Again, we're going to hold Control down and press Tab until the assembly is highlighted, and then we can release Tab. When the assembly loads, you may be asked to rebuild the assembly, and you want to go ahead and select Yes. The assembly has also updated the instance of that part in it for the new sizes that we created. And lastly, if we right-click and expand our right-click menu, we can select Open Drawing for the assembly. When the assembly drawing opens, we can see that all of the changes we made to the part are also reflected on the assembly drawing. So with that, I trust you do have a firm understanding of all the SolidWorks file types and how they interact with each other. And I hope you found this lesson to be informative and engaging. Go ahead and close out of these files without saving your changes, and you're ready to move on to the review exercises.